Bright QT. Every student matters.
Hello students, now we will be taking up the numericals based upon the combination of resistances in series and in parallel. Let us see. Now this is quite important. You need to understand all the things. The first question that will be given to us is what possible values of resistances may be obtained with two resistances of values 2 ohms and 4 ohms, right. So, we know that we can combine these two resistances in two ways. Let this first resistance be R1 of 2 ohms and the second resistance be R2 of 4 ohms, right. So, now we have got two options. First option is we can connect them in series or we can also connect them in parallel. If I connect them in series, then in that case I know that total resistance which is to be calculated in series combination is given by the formula R1 and R2. Here R1 given to me is 2 ohms and R2 given to me is 4 ohms. So, therefore, the total resistance that I will get in series combination is 6 ohms. If I connect these two resistances in parallel, the total resistance is calculated by the formula as we already have studied, that is 1 upon R is equal to 1 upon R1 plus 1 upon R2, right. So, putting the values, I will get R1 is given to be 2 ohms, R2 is given out to be 4 ohms. Taking the LCM, that is my 4 ohms, I will get 2 plus 1, that is 3 by 4. Mind you, this is 1 upon R. So, for calculating R, I will be just taking the reciprocal, that comes out to be 4 by 3 ohms. So, if I am given two resistances of 2 ohm and 4 ohm, I can get these two resultant resistances of 6 ohms and 4 by 3 ohms, connecting them in series or in parallel respectively. Understood? Now, the second question which may come may be, how will you get the smallest and largest value of resistances given below? There is a 4 ohm resistance and an 8 ohm resistance and a 12 ohm resistance and a 24 ohm resistance. We are given 4 resistances. Let it be R1, this is R2, this is R3, this is R4. We are just asked that how we will get the smallest value and the largest value out of these 4 resistances and also calculate the resistance in each case, that is the smallest value and largest value. Now, we have already studied that if we add up the resistances in series, then we will get the maximum or the largest value. So, in order to get the largest value, we will connect all these 4 resistances in series, and when we connect them in parallel, we will get the smallest value, right. So, let us see what are the various values that we get by connecting them. If I connect them in series, then the total resistance, let it be RS or resistance in series, that comes out to be the sum total of all the individual resistances, that is R1 plus R2 plus R3 plus R4. I'll just add them up. 4 ohm plus 8 ohm plus 12 ohm plus 24 ohm, that comes out to be 48 ohms. So, this is the largest value that I can obtain by combining these 4 resistances. Now, talking about the smallest value. For smallest value, I will connect them in parallel, and then I need to calculate the resistance in parallel. I am denoting it with R, resistance P, right. Now, in parallel, I know that the total resistance is given by the formula 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. Now, putting the values out here, I get 1 upon 4 ohms plus 1 upon 8 ohms plus 1 upon 12 ohms plus 1 upon 24 ohms. When I take the LCM comes out to be 24. So, here I will take 6 plus it is 3 plus it is 2 plus it is 1. Fine. So, getting the total of it, 6 plus 3 9 plus 2 11 and 1 12, it comes out to be 12 by 24. Striking it off, I will get 1 by 2. Now, this is 1 by R. So, if I will be calculating the resistance, then I will be taking the reciprocal and it will become 2 ohms. So, this is the smallest possible value of total resistance I can get by using these 4 resistances. So, for getting the largest value, I will connect them in series. For getting the smallest value, I will connect them in parallel. In series, when I connect them, I get the total resistance of 48, which is the maximum possible resistance I can get, and when connecting in parallel, I will just get 2 ohm total resistance, which is the smallest possible value of resistance using these 4 resistances. Got it? Now, next type of question that may be given to us is, we are given a resistor or a resistance, one of the same thing, of 8 ohms is connected in parallel with another resistor, and I am not given the value of this resistor. This is X. The resultant resistance, of this combination is 4.8 ohms. What is the value of X? Now, this question has been changed a bit. What is the value of X? Let us see what exactly the question is saying to us. It is saying that a resistor of 8 ohms, let this resistor be R1, this is the first resistor given to us to be 8 ohms, is connected in parallel with another resistor X. So, let this be second resistor X. This is X ohms, we do not know the value of it, right. The resultant resistance of the combination, that means total resistance, is given to us to be 4.8 ohms. We have to calculate the value of X, that is R2. Now, since they are connected in parallel, we know that in parallel combination, the total resistance is given by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2. Got it? Now, in this question, R is given to us, R1, the value of first resistance is given to us. We can easily find the value of the second resistance. Let us see how. Putting the values over here, I will just write 1 upon 4.8 ohms is equal to R1 is given to be 8 ohms plus R2 I don't know, I am just putting the value to be x itself only, right. Just taking 1 by x, keeping it here and taking 1 by it at the opposite end, I will get 1 by x is equal to 1 upon 4.8 minus 1 upon 8. Removing the decimal, just keeping 10 out here. So, now I will just try to find out what exactly is the LCM and how to further continue it. 1 by x is equal to, I will take the LCM to be 48, we are left with 10 as it is, minus I will take 6 over here. So, I am getting 1 by x is equal to 4 upon 48, cancelling it out with 12, I got 1 by x is equal to 1 by 12 and taking the reciprocal, I will get x is equal to 12 what? Ohms, that is a unit. So, this is the value of x, right. So, if I take a diagrammatic figure wise presentation of this, so in the question we are being said that this is one resistance of 8 ohms, right. Now, if I connect it with the second resistance of which we have find the value to be 12 ohms, and then if we calculate the total resistance of these two, we will get the total resistance to be 4.8 ohms, right. So, you may be asked the question in this way also. Got it? Fine. Now, students, till now you have seen that we are combining the resistances in either series or in parallel, right. So, let me tell you what are the possible ways to combine resistances. Now, first way was we can combine them in series combination. If I am given 1, 2, 3, 4, 5 resistances, I am connecting it in the circuit in series, right. Let us take 2 or 3 resistances. This was first resistance combined with second resistance combined with third resistance R1, R2 and R3. So, this is the first possible way by which we can combine the resistances, and as per what we have studied till now, if I combine the resistances in series, I will get the maximum possible value. So, if in the question I am given any 3 resistances and I am asked to find out the maximum possible value, in that case I will combine them in series. So, I am giving you a tip, there are 2 things that we need to see. First thing is, if I am given in the question that I need the largest possible value using these 2, 3, 4 resistances, I combine them in series. And second very important tip, students, that is कि whenever we will combine the resistances in series, we will see that the total resistance is always greater than any other individual resistance. That is, R should be greater than R1, it has to be greater than R2, it has to be greater than R3 and so on. So, these are the 2 things that we keep in mind if we are connecting the series in the resistances in series. Got it? The second possible option that we had got are connecting these resistances in parallel. Now, these were the 3 resistances given to me. This is the first resistance. In parallel, I have taken the second resistance. In parallel, I have taken the third resistance. So, this is my resistance R1, this is R2, this is R3. This is the second possible option. In these 2 options, I will be combining my resistances when I want the lowest possible value of total resistance. I need to get lowest possible value of R. Second thing, when I am connecting them in parallel, I will find that the total resistance is always less than any individual resistance, that is R will be and should be less than R1, it should be less than or it should be less than R2 and R3, right. So, these are the two things that already I am aware of. I am telling you yet another way of combining. Now, this is quite important. What we will do is we will combining a resistance in parallel, not yet completed, fine, it is not same as that of the above, combining a resistance in parallel to a combination of two resistances combined in series. Just hang on, I will be explaining it up, do not worry. Now, I am given three resistances R1, R2 and R3. What I have said is combining a resistance in parallel to a combination of two resistances combined in series. So, I will take a combination of two resistances in series. Let it be the first resistance R1, the second resistance R2. To this combination, now I am connecting my third resistance in parallel combination like this. This is also one of the possible ways of combination. Very, very, very important, students, try to understand what I am relating. We will use this type of combination when there are certain reasons or certain tips for using this combination. If I am given three resistances R1, R2 and R3 such that the sum of two resistances is equal to the sum of the total of the third. That is, for example, if I am given one resistance of 2 ohm, second resistance of 3 ohm, third resistance of 5 ohm. So, here I see that 2 plus 3 is equal to 5. Similarly, I can be given three resistances 1 ohm, 2 ohm and 3 ohm. Here I can see that the sum of lower two resistances is equal to the third. This is my first criteria which I will be following. Very importantly, there is second criteria too. If we need the answer to be half of R3, the bigger resistor, then we will combine these like this. Now, let me clarify it so that you may be able to better understand it. I will be asked in the question what? That we are given three resistances 2 ohm, 3 ohm and 5 ohm. How will you connect these resistances so as to get a total resistance of 2.5 ohms? Now, first of all, if I connect it in series, I can't. Why? Because in series I know that the total R should be more than any other individual resistance, which it is not. Second thing, I cannot connect it in parallel. Why? Because same thing, the total R should be less than all the individual resistances, which it is not. So, I will be going for the third option. The third option, for taking it as a third option, we need to know that is it fulfilling our these two criteria. First criteria is the sum of two resistances is equal to the third one, and the answer required is the total resistance required is half of this. Now, I will connect in this way where I will take the smaller values 2 ohm and 3 ohm in series and the bigger value of 5 ohm in parallel. Let us see, if I connect them, how do I get my required resistance? This is 2 ohm resistance, this is 3 ohm resistance, and I am connecting it with a 5 ohm resistance. Now, how will I get the resultant resistance? Let us see. I see that these two resistances are combined in series, and when I talk about R1 and R2, I want to take the total of these, and since they are in series, what I can write is the total resistance. Let us give us a name of R4, that should be equal to R1 plus R2, which comes out to be 2 plus 3, that is 5 ohms. So, instead of just showing these two resistances, I can convert this figure into this figure, where I will take, rather than taking 2 ohm and 3 ohm resistance, I will take the sum of that, the total resistance of these two resistances, which comes out to be 5 ohms. Next, we were already given 5 ohms. Now, I can see that these two resistances are connected in parallel. So, now if I find, now this resistance I have given the name R4, this resistance was already R3. If I will be connecting the total resistance R, that should be equal to 1 upon R4 plus 1 upon R3. Why? Because now they are connected in parallel, and when they are connected in parallel, the reciprocal resistance is equal to the sum of reciprocal individual ones. Now, putting the values, R4 is 5 ohms, R3 is yet again 5 ohms, taking the LCM to be 5, I get 1 plus 1 comes out to be 2 upon 5. Taking the reciprocal, R will be equal to 5 upon 2, which comes out to be 2.5 ohms. Answer, this is what I was requiring. So, you see, whenever I am given this particular option in the question, that you are given 3 resistances, 2 ohm, 3 ohm and 5 ohm, how will you connect these resistances so as to obtain a resultant resistance of 2.5 ohms? Then I will be using this particular combination. The two conditions, I repeat, should be fulfilled. The first two resistances should be adding up to give the sum as the third resistance, and the answer required should be half of this particular final, the bigger one resistance. Got it? Fine. So, this is how we will take out the third type of combination. And if all these three are not working out, we have talked about 3 combinations. If all these 3 are not working out, then in that case we still have an option left. How? Now, we will connect what? Combine a resistance in series with a combination of 2 resistances in parallel. It is just the opposite of the third one, third case. Let us see what exactly we have written over here and how it will appear. Now, if the 3 resistances were given to me, then I am combining one resistance in series with a combination of 2 resistances in parallel. There were 3 resistance given to me, R1, R2 and R3. Fine. In this case, I will take 2 resistances in parallel and then combined this particular parallel combination with in series with the first resistance. Got it? Fine, right? Now, the question you will be getting over here, let us see. We have seen the 4 combinations, possible combinations, right? Now, we will apply how to get our particular answer. Let us see. The question, first question is given is, you are given 3 resistances R1, R2 and R3. You are given 3 resistances of 1 ohm, of 2 ohm and of 3 ohms. We will be asked in the question, how will you connect these 3 resistances so as option number 1, we will get total resistance to be 6 ohms. This is our first possibility. Second question he will be asking is, you have to combine them in such a way so that total resistance comes out to be 6 by 11 ohms. And the third option he will be asking is, combine them in such a way that the total resistance should be equal to 1.5 ohms. Right? Now, we are given 3 resistances and we are left with these 3 options. Firstly, we have to combine them in such a way that the total resistance is 6 ohms, or second case 6 by 11 ohms, or third case 1.5 ohms. Right? So, let us see, the first option we had was combining them in series. So, if I want to get 6 ohm resistance, now first thing I can very well see that the total is coming to be 6, otherwise also this 6 total R is more than R1, is more than R2, is more than R3. So, the first trial we will be giving is connecting it in series. Counter checking it, if I connect them in series, the total resistance in series is the sum total of all the individual resistances. That comes out to be R1 is 1 ohm, R2 is 2 ohm, R3 is 3 ohm, that comes out to be 6 ohm. So, this is the answer of my first part, that if I want the total resistance to be 6 ohms, then I will connect them in series. Got it? Now, let us take the second option. If I connect them in parallel, what do I get? In parallel, I know that the total resistance is calculated by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Putting the values, I will get 1 upon 1 ohm plus 1 upon 2 ohm plus 1 upon 3 ohms. Right? Taking the LCM, 1 upon R is equal to, this is the LCM that we will take the LCM to be 6. Here we will get 6 plus 3 plus 2, that comes out to be 11 by 6 ohms. This is 1 upon R, taking the LCM, R is 6 by 11 ohms. So, if I connect them in parallel, I will get my second answer, that my total resistance will be 6 by 11 ohms. Got it? Now, this is important, 1.5 ohms. Right? How will I get 1.5 ohms? If I have connected them in series, I have got 6 ohms. If I have connected them in parallel, I have got 6 by 11 ohms. The third case. Now, the conditions being fulfilled over here, I need to see whether the criteria is getting fulfilled. How? We are given 1 ohm, 2 ohm and 3 ohm. The first condition we wanted was that the sum of the initial two lower resistances should be equal to the third one. The second condition was that my answer should be half of third one, and this is half of third, that is 1.5 ohms. So, now I am satisfied and I can directly put up these values in this particular R third case, that I will put up two smaller resistances in series, that is of 1 ohm and 2 ohm in this particular question, and placing them in parallel with the third resistance. Now, if I will calculate the total resistance, I will get the answer 1.5. Let us counter check. Now, this is, let it be R1, this resistance let it be R2, and this 3 ohm resistance let it be R3. So, first of all, as I can see, these R1 and R2 are in series. So, I will take a resultant rather than taking these two, and I will give that resistance the name R4. R4 will be equal to R1 plus R2 as they are in series. This is 1 ohm and this is 2 ohm. It comes out to be 3 ohms. Right? So, now I can change this figure like this, ki instead of writing two resistances I'll write one resistance, a combination of R1 and R2 given by R4, and this is of 3 ohms. The second resistance was as it is, that of 3 ohms. Now I see that this R3 and this R4 are in parallel to each other. So now I'll be calculating the total resistance denoted by capital R. Now it will be the sum total of reciprocal of R4 and R3. R4 is 3 ohms, R3 is yet 3 ohms. Again taking the LCM 3, I will get 1 plus 1, it comes out to be 2 by 3 ohms. Taking the reciprocal, R comes out to be 3 by 2 ohms, cancelling it, I will just get 1.5 ohms. That is my answer. You see, fine, got it. So this is the third possible option. Now looking out a question for fourth possible option. Let us see. Now this is interesting, this is good question. Please try to relate. Where we will given a question that we are given 3 resistances. We are given 3 resistances of 2 ohms, 3 ohms and 6 ohms. How will you connect these resistances to get a total resistance of 4 ohms. Alright. Now, this first resistance we give it the name R1, this is the second resistance R2, this is the third resistance R3, and this is the total resistance that we require. Now, as per our till now understanding, we know that I am just guessing, alright. If I will be keeping it in series, I can't, because in series I know that the total R is greater than R1 or R2 or R3. This R is 4 ohms, which is greater than R1, which is greater than R2, but not R3. Therefore, series combination can't work here. Second option I had was in parallel combination. Now, in parallel combination also we won't find the required answer, because in parallel combination the total resistance should be less than R1 or R2 or R3, any other individual resistance. So, this 4 ohm is not less than R1 or R2. So, parallel combination if we will try, we will not get this particular answer. After these, we were having third case where we had 2 resistance in series with a combination of third in parallel. This will also not work here. Why? Because it is not fulfilling our condition. You remember what conditions had we placed? We had placed the first condition to be that the first resistance and the second lower resistance, the total should be equal to third, which is not here. That is 2 ohm and 3 ohm, 2 plus 3, it is not equal to 6. And the answer required is not half of the third resistance, that is 6 ohm. The answer required is not 3 ohms, it is 4 ohms. So, that means we are left with now the fourth option. When all the 3 initial options do not work, we will just try the fourth option. What did it say? It said we will take a series resistance with a combination of 2 parallel resistances. Got it? Now, which to take in series and parallel? The lower one to be taken in series, 2 ohm, 3 ohm and 6 ohm will be taken in parallel. Will it give us the answer 4? Why not to check it out? Let us see, let us calculate. Now, this was our R1, this was our R2, this was our R3. From this question, we can relate that R2 and R3 are in parallel. So, what I will do is, First of all, I will take one resistance instead of these two, and for that I will calculate the combined resistance of this one R2 and R3. Since I can see that they are in parallel, so I will calculate their total and I will give it a name R4. Why R4? Why not R? Because R will be taking as the combined resistance of the whole circuit, which it is not, it is just a part of it. So, I will calculate R4 with the formula 1 by R2 plus 1 upon R3. What is R4? The combination of R2 and R3. And since they are in parallel, I will be taking in reciprocal. Putting up the values, I will get 1 by 3 ohm plus 1 by 6 ohms. Taking the LCM, LCM comes out to be 6, I will get 2 plus 1, which comes out to be 3 by 6 or 1 by 2. This is, mind you, 1 upon R4. So, reciprocal R4 will be equal to 2 ohms. So, the combination of this 6 ohm and 3 ohm resistance comes out to be 2 ohms. Now, what I can do is, I can redraw this figure like this. This was our initial R1 2 ohms, and on taking the total of these two, what I can do is I can place the resultant value 2 ohm of R4 here, right. You can relate it. Now, it is simple that these two resistances R1 and R4 are in parallel to each other. So, now the total resistance will be, they are in series to each other. Now, the total resistance will be the sum total of R1 and R4, which comes out to be 2 ohms plus 2 ohms, and our answer is 4 ohms, right. So, this is how we will connect our two resistances in parallel with a combination in series with the third one, and we will get the resultant resistance of 4 ohms. Got it? So, these are the possible combinations of resistances that we can do in order to get a resultant resistance of desired value. All the four, I hope you have understood, right.